Hello dear students, welcome. I am Dr. Poornima A S and today I am going to teach you the concept of combination in solving problems of probability. Okay, let us go to the question directly. I am going to read the question. A bag contains 4 white and 6 black balls. 2 balls are drawn at random. What is the probability that A, both are white, both are black, and one white and one black? This is case A. Now, the next case B written in green, there are 2 balls are drawn one after the other with replacement. What is the probability that both are black, both are one white and one black, both are white, both are white, both are black, and one white and one black? Now, what is the difference between case A and case B? It is important to know so that you do not make mistakes while solving. 2 balls are drawn at random. In this first case, what happens is there are 4 balls, that is, there are 4 white balls and 6 black balls in a bag. 4 white and 6 black balls in a bag. You have to imagine that. You just shake a bag and then take 2 balls and note down the color. Case A is that. Case B, it is not. 2 balls are drawn one after the other. That is, there are 4 balls, 4 white balls and 6 black balls. Similarly, in the just like the previous case, but here instead of taking 2, you are taking 1 ball. You are taking 1 ball. Say, noting down the color, putting the bag, putting the ball inside the bag again shake it up and take 1 more. So then 2 balls are drawn one after the other with replacement. With replacement means as soon as you take the first ball, you note down the color and throw it back in. That is, you are replacing that ball inside the bag itself. So this is about the understanding of the problem. Now, let us go to the concept of combination. You need to know the concept of combination with, if you have to understand this. So a concept of combination says whenever there are n items in this set and the number of items to be selected from the set is r, then NCR is equal to n factorial divided by n minus r factorial into r factorial. Now, we have to find the total number of ways. You know the probability concept. The probability is number of favorable cases by total cases. Okay, sorry, forgive my handwriting, but total cases. So here, now to find the total number of cases, we have 10 balls here in all, then of which we are taking 10 C2 cases. 2 balls are drawn at random. Okay, what is the probability that both are white, both are black? That case A we are going to solve now. So it is equivalent to 10 factorial divided by 10 minus 2 factorial into 2 factorial. Okay, so how to solve this problem? We will go to the next slide. See, bag contains 10 balls. 2 balls can be drawn from 10 balls in 10 C2 ways. Okay, 10 C2 ways. and that is equivalent to 10 factorial by 2 factorial into 10 minus 2 factorial. That is, we are now trying to find total number of cases. Total number of cases. Okay, so this is number of favorable cases. And this is also the third one also. We are trying to find out the favorable cases. Okay. So how do we draw this 10 factorial? By 2 factorial into 10 minus 2. I'm just explaining. At any numbers and you put a factorial sign beside this means you have to expand it into 10 into 9 into 8 into 7 into 6 into 5 etc. till 1. That is equivalent to 2 into 1 into 8 into 7 into till 1. So when we divide this, we just cancel this out. That is equal to 10 into 9 by 2 into 1. That is equivalent to 45 different ways. 2 white balls can be drawn from 4 white balls in 4 factorial by 2 factorial into 4 minus 2. Here again, it will be 4 factorial is equal to 4 into 3 into 2 factorial divided by 2 factorial into 4 minus 2, 2 factorial. 4 into 3 by 2 into 1, that is again equivalent to 6 ways. That is what we have got. Number of favorable cases. 2 black balls can be drawn from 6 black balls in 6 V2 ways. That is 6 factorial by 2 factorial into 6 minus 2. So 6 into 5 into 4 factorial divided by 2 factorial into 4 factorial. 6 into 5 by 2 into 1, that is 3 into 5, 15 ways. Now, let us go to case A, stage A. Here we have probability is equal to number of favorable cases by total number of cases. We have calculated that the probability is equivalent to 4C2 divided by 10C2. 4C2 we have calculated in the previous slide, that is divided by 10C2, that is equivalent to 6 divided by 45. So both are white. Now both are black. Probability is number of favorable cases by total number of cases. In this case, we have 6C2 divided by 10C2, that is equivalent to 15 by 45, that is equivalent to 1 by 3. Okay, so this is about how we are solving the first case. Very simple. Now 1 white and 1 black. P of 1 white and 1 black is equivalent to 4C1 into 6C1 by 10C2. Why? See, we have taken 2 balls and noting down the color, what is the probability that one is white and one is black? So the number of favorable cases, what you have to write, number of favorable cases, total number of cases will not change because it is 10C2. 2 balls are drawn out of 10 balls. Here, one of them has to be white and another should be black. Means one white ball can be selected out of 4 white balls in 4C1 ways, and one black ball can be selected out of 6 black balls in 6C1 ways. 4C1 into 6C1 by 10C2. That is equivalent to 4 into 6 by 45. That is, any number 4C1 is equivalent to 4. Any number combination 6C1 is equal to 6, 10C1 is equal to 10. But we have used 10C2 here. 4 into 6 divided by 45, that is equivalent to 24 by 45. Now, so case A is completed. What is the case A? There are 4 white balls and 6 black balls in a bag. We are taking 2 at a time, 2 balls at a time. Then we have to find the probability of both are black, both are white, and one white and one black. So accordingly, we have understood previously. Now, case 2 is something different. A bag contains, I have again put this slide only for your understanding. A bag contains 4 white and 6 black balls. 2 balls are drawn one after the other. There are 4 white and black balls. 2 balls are drawn one after the other with replacement. That is, you take one, note down the color and put it back. What is the probability that both are white, both are black, one is white and another is black? Now, in this case, case B, we have 2 balls are drawn one after the other. That is, the first ball is taken, noted down the color and put back in the bag. Then the second ball is taken. The second ball is taken and noted down the color. So the required probability is probability of first ball being white and second ball also being white. That is, one ball can be taken out of 4 balls in 4C1 ways. That is number of favorable cases. 10C1 is the total number of cases, because here why we are not using 10C2, because we are choosing only one ball. In the previous case, we were choosing 2 balls. That's why we were putting 10C2. Now we are choosing only one ball. Therefore, we are noting down the color. Therefore, it is equivalent to 4C1 by 10C1 into 4C1 by 10C1. That is equivalent to 4 by 10 into 4 by 10. That is equivalent to 16 by 100. That is equivalent to 0.16. In case B, both are black. In this case, 2 balls are drawn one after the other. That is, the first ball is taken, color is noted and put back to the bag. Then the second ball is taken. Probability that the first ball is black and the second ball is also black is equivalent to 6C1 by 10C1 into 6C1 by 10C1. That is equivalent to 36 by 100. Why 6C1? One black ball has to be selected from 6 black balls. So therefore, it is 6C1 by 10C1. Again, it is put back. Again, the required probability stipulates that you have to take one more ball. Therefore, it is equivalent to 6C1 by 10C1. That is equivalent to 36 by 100 or 0.36. So the required probability translates to, see, yeah, 36 by 100, that is equivalent to 0.36 here. Okay. Case C is one white and one black. In this case, again, two balls are taken one after the other. That is, the first ball is taken, color is noted and put back, then the second ball is taken. So the required probability translates to probability that the first ball is white and the second ball is black. That is equivalent to, and the second ball is black, that is 4C1 by 10C1 into 6C1 by 10C1, that is equivalent to 24 by 100, that is equal to 0.24. Now, that's all, dear students. I hope you have understood the concept of combination used in probability. Happy learning.